Welcome to the review for benchmarks. So this is the first podcast. The concepts aren't going to be done in any particular order. We've got 5 concepts. First one I'm going to look at is systems. This podcast I'm just going to continue until I'll at least finish the systems, but I don't want this podcast to be too long. I'd rather make several podcasts than have a really long podcast. All right, so here's our first problem, and we want to solve the system of equations by graphing. And one of these is correct, and the others are not. So how do you figure out which it is? All right, so, well, first of all, we could look at are these the right equations? Second of all, we could look at the solutions and see which one has the right solution, because notice none of these solutions are the same. And so we could find our solution algebraically and match it. So that's just 2 different ways. We could figure, and maybe we want to do a little of both. All right, so either we have to figure out which is the correct set of lines, or we need to figure out which is the correct solution, maybe using algebraic techniques. All right, so if we're going to look at slope, we want to isolate our variables, or isolate y. So we have negative 4x. Come on. I'll try that again. All right, so negative 4x plus 3y equals negative 12. Add 4x to both sides, so we have 3y equals 4x minus 12, and then divide by 3. So we have y equals 4/3 x minus 4. That's one of our equations. Right? So now let's take a look. Can we rule any of them out? Well, they all go through the right y-intercept. We just have to make sure that, notice this equation has a positive slope to it. And so one of these equations does not have, actually 2 of them, does not have, no, only one, this one right here, has the wrong slope. So this is a negative slope right here. So that one that's not the right graph. So we can eliminate that one. And so let's rewrite the other one into slope-intercept form. All right, so we've got negative 2x plus 3y equals negative 18. All right, so add 2x to both sides, so we have 3y. Oh, and I dropped my pen down there somewhere. Oops. I guess I have to go find my pen before I can erase. There we go. Right, so we have 3y equals 2x minus 18, and then divide everything by 3. So y equals 2/3 x minus 6. Again, positive slope. And a y-intercept of negative 6. All right, so let's see. Well, one is the incorrect slope. So right here, we got a negative slope. That's not correct. Our line has a positive 2/3 slope. It's really hard to distinguish between these 2 graphs that are left, A and B, by looking at the equation. So we're going to have to solve the system. We could use substitution again, or we could use linear combinations. Actually, linear combinations in this case would be a lot easier, I think, than with substitution. But maybe since we've already isolated the variables, we'll use substitution, and then I'll show you linear combinations on this problem as well. All right, so both of these equations are equal to y, which means they're equal to one another. We can just substitute what follows for the y. So we have 4/3 x minus 4 equals 2/3 x minus 6. I don't really care for having all these fractions in here, so let's multiply every term by 3. That is the least common denominator, and if we do that, then we will get rid of the denominators. Right? So And as long as we do it to everybody, every single term, then we're okay. So here the 3's would cancel, and I've got 4x minus 12 equals, here the 3's cancel, and we've got 2x minus 18. So there, we got rid of all of our denominators. Now we just need to get the x terms on one side and the constants on the other. So we'll subtract 2x from both sides. And we have 2x minus 12 equals negative 18. I think I wrote the negative in. There you go. And so then our last step is to add, come on, 12 to both sides. There we go. Not our last step, but almost our last step. All right, so we'll add 12 to both sides. Hopefully this isn't too low on the screen, that you can still see it. So we have 2x equals negative 6, and divide by 2, and x is 3. Negative 3. Okay. So hopefully you can see those problems okay. They're not too low. So now let's match it up. Which one had the solution where x is negative 3? Well, there's only one. We don't even need to find the y-coordinate because there's only one that meets everything. Okay? Matter of fact, there's only one that has the right solution at all, and that's B right here. So B is the correct system of equations that's shown. Okay? So you can use the slope to help you, and then use your solutions to tell you. Okay? You want to make sure you have all of the pieces of information. So I'll show you really quickly, by the way, how to solve this with linear combinations. With linear combinations, you want to add them together so one of your variables drops out. So here, notice these y's are almost the same except for the sign. So I'm just going to multiply all of the terms in that equation by negative 1. Okay? So, and I'll take the second equation. I'll multiply that by negative 1. So I'm going to multiply that first one by negative 1, and the second one by negative 1, and the third one by negative 1. So my first equation didn't change. Negative 4x plus 3y equals 12. And if I multiply the negative 2x by negative 1, I get a positive 2x. If I multiply the 3y by negative 1, I get a negative 3y. And if I multiply the 18 by negative 1, I get a negative 18. And notice it's looking a lot like what we had after we multiplied everything by 3. So now if we add those equations together, negative 4x and a positive 2x gives us a negative 2x. 3y minus 3y is 0. And 12 minus 18 is a negative 6. So oftentimes it's easier to solve linear equations using what's called linear combinations. So it's called either linear combinations or elimination. Linear combinations because you're combining linear terms, and elimination because when you combine, one of your variables drops out. And now we'll just divide by negative 2. X is, why do I have a sign error unless I misread one of my values in there? Was that because I have a negative 2x, and here I show x equals positive 3, and that's not right. Maybe I should write it a little bit larger. Maybe it's so late I can't read my own handwriting. Oh, that was a negative. Okay, that was a. All right, I'm going to write that again. So negative 4x plus 3y equals negative 12. We multiplied everybody by negative 1. I'm going to write it down here. So everybody gets multiplied by negative 1 because we want the y terms to drop out. And they're both positive right now. All right, they're both positive. So negative 2 times negative 1 is a positive 2x. Positive 3y times a negative 1 would be a negative 3y. And, negative 18 times negative 1, that was where my mistake was. I accidentally wrote that this was negative. That was positive. So that's going to give us a positive 3 there. Now that makes more sense because that's negative 2x equals positive 6. And divide by 2, x is negative 3. Sorry, when I wrote it down, I miswrote down one of the signs. So x is negative 3 is our solution, and we could plug it back in to solve for y. Okay? So really, linear combinations was much less work, as you can see, and it's just a technique you can use when you're solving linear equations. Just make sure you don't cram your work too much and that you can't read your numbers, because you might make a math error like I did for a second there until I rewrote it. Okay? So here's the solution for this one. Just make sure you find your solutions and you make sure that it makes sense with your equations, with the slope of your equations. Okay? This one took us a little longer than I thought it would, okay? But maybe this one will take us less time. So the rest of these we're going to solve using substitution. We'll always use substitution or graphing when it is when we have any nonlinear equations, and we're not going to graph these. The rest of these are algebraic. So what's the solution set of this system of equations? All right, so we have to get a variable isolated, and the one to get isolated is the y. All right, so we have x squared minus y equals negative 3. Let's subtract the x squared from both sides. So we have negative y equals negative x squared minus 3. And then divide everybody by negative 1. So we have y equals x squared plus 3. I need to learn to write smaller. All right, moving on the other side here, we will take care of the 2x squared minus y equals negative 2. Subtract the 2x squared. So we have negative y equals negative 2x squared minus 2. And then divide everybody by negative 1. So we have y equals 2x squared plus 2. All right, so our equations are now isolated for y. They're both equal to y. We can set them equal to one another. And I think I'll move over a little bit over here. So we have 2x squared plus 2 equals x squared plus 3. All right, move everybody to one side. So we're going to subtract the x squared and subtract the 3. So we have x squared minus 1 equals 0. This is a difference of squares that factors into x plus 1, x minus 1 equals 0. Our two solutions, if x plus 1 is 0, x is negative 1, x minus 1 is 0, x is 1. So there we have our solutions. We do have to plug it back in into one of the equations. It doesn't matter which one. I think I'll take the first one. So we have, so it's x squared minus y equals negative 3. So we have negative x squared minus y equals negative 3. Negative 1 squared is a positive 1 minus y equals negative 3. Subtract 1 from both sides. Negative y equals negative 4. And so y equals 4 is one solution. So one of our solutions, I'll just put it over here, is negative 1, 4. And then the other solution, we have 1 squared minus y equals negative 3. And so that's just 1 minus y equals negative 3. Subtract 1 from both sides, and you see we're going to get the same solution. So y equals 4. So we have negative 1, 4, and 1, 4. And the set that has that is D. D is the correct one. Okay. And good idea, I'm not going to do it in the podcast, is to check your answers in the other equation. Because you don't want to make a mistake here. Make sure you look at those carefully. You can plug them back into the other equation and check and make sure it works. Okay, so you should get a true statement. Okay? And if you get stuck and you need to, you can always check these in both the equations and see which one gives you the true statement. Okay? But I don't think you'll have trouble solving these. These weren't so bad. All right, so here, what's the solution to the system of equations? We need to isolate y in both of our equations here. This one was a little bit trickier than the ones that we've been working on in class. And actually, I'm not going to isolate y in this equation right here. I'm going to leave that y just the way it is, because actually it will be easier. Okay, so because otherwise I'm going to have a 1/7 x and a 31/7 and have a lot of strange fractions. So I'm going to leave that. I'm just going to isolate y in the other equation. So I have y minus x equals 3. We'll add x to both sides, and we have y equals x plus 3. What we're going to do is, where we see a y in this equation, we're going to replace it with an x plus 3. So we have x squared minus 7 times x plus 3 plus 31 equals 0. Now, make sure you distribute that negative 7 to the x plus 3. So we have x squared minus 7x minus 21 plus 31 equals 0. So that's x squared minus 7x plus 10 equals 0. And now we can factor that. Okay, so you don't want a bunch of fractions. It would be better just to leave it just the way that second equation is and just replace the y with the x plus 3. So multiplies to give me 10. 1 times 10 is 10. And adds to give me negative 7 would be negative 5 and negative 2. So we have x squared minus 5x plus a negative 2x plus 10 equals 0. First two become a group, second two become a group. We'll pull out the x and we have an x minus 5. Pull out the negative 2 and we have x minus 5. So this all factored is x minus 2 and x minus 5. So our two solutions here are x equals 2 and x equals 5. Well, these two have the wrong x values. Plug it back in to find the right y values. We should plug it back into the easiest equation to work with, and that's that first one. So y minus 2 equals 3. So y is 5. And now we still can't tell for sure because 2, 5 is a point in both of them. And then y minus 5 equals 3. Add 5, y equals 8. So our solutions are 2, 5, and 5, 8, which is B. B is the right set there of answers. All right? So we've looked at a linear and a quadratic. We've looked at two quadratic. We've looked at a linear. Now we're going to look at another linear. Okay? And we could either use linear combination or substitution here. And actually, the substitution is not too difficult at all. You could substitute the 2x plus 1 for the y, but you'd have to remember to distribute because there's a negative in front. Or you can rewrite that one in slope-intercept form. I think I'm just going to put it in slope-intercept form, because that's not too difficult to do. So this one, we'll just isolate y here. So we have, we'll subtract 3x from both sides. I'm just going to write it though. 3x minus y equals 4. We'll subtract 3x. So we have negative y equals negative 3x plus 4, and then divide everybody by negative 1. So y equals 3x minus 4. Okay, so now that's isolated, and we can take that 3x minus 4 and replace it with y in the other equation. So we have 3x minus 4 equals 2x plus 1. Subtract 2x from both sides. This is a pretty easy solve. X minus 4 equals 1. Add 4 to both sides, and x is 5. So 5 is our solution. We don't even have to plug in for y. There's only one here. Oops, I was hoping to make that look a little better. I wrote right through my x. There's only one here that has 5 as the correct x value, so the y value doesn't even matter. We could figure it out from the x. Okay? And you can always plug it back into the other equation, see if it works out. So I'll do it real quick. So if I plug it into one of our equations here, I'd have, so y equals 2x plus 1, and y equals 2 times 5 plus 1, and that would be 11. And that matches. So, you can always check it by plugging it in, making sure you get that value. Whoops. And you can always plug it back into the other equation to really check. But here we could tell just from the x, which was the answer. Okay. One more problem for us looking at systems. All right, so the functions f and g are defined below. Which ordered pair represents the intersection point of the graphs? So the intersection point is what they have in common, and where they intersect, there's going to be some point where the x values are equal and the y values are equal. Okay? So this f of x is the same as y. This is the same as y equals natural log x squared minus 2. And this is the same as y equals natural log of x. Okay, so if we're looking for the intersection point of the graphs, we're looking for the point they have in common, the solution, and we can, it's just worded a different way, but we are just setting those two equal to one another to see where they are equal, where they meet each other, where they intersect, however you want to look at it. All right, so we have natural log, maybe I'll solve it up here. Oops. I have to remember to put down the pen when I erase. All right, I'll solve it in red. So we have natural log x squared minus 2 equals natural log of x. Okay? So remember, when the log functions match, you can drop the logs and set what's equal, what follows equal. So we have x squared minus 2 equals x. We need to subtract x from both sides. So we get everything on one side, so we can factor. X squared minus x minus 2 equals 0. We want to factor. 1 times negative 2 is negative 2. Multiplies to give us negative 2. Adds to give us our b term of negative 1. That would be negative 2 and 1. All right, so that's going to be, I'll just keep going down here, x squared minus 2x plus x minus 2 equals 0. First two become a group, second two become a group. Pull out the x and you have an x minus 2. Pull out a 1, x minus 2. And so this factored is x plus 1, x minus 2. And we have two solutions here. X equals negative 1 and x equals 2. Now, log functions you need to check. So when I said you don't have to check on the systems, I was not referring to log. Log we can get extraneous solutions, so we have to check. All right, so let's check our answers and solve. Okay, so we have to find the y values anyway. It doesn't matter which equation you use to check and to find the y values. Let's just use the g of x equals natural log of x. So if we plug in negative 1, so g of negative 1, we get natural log of negative 1. Okay? And you can use your calculator, and if you try plugging that into your calculator and you ask for a natural log of negative 1, it's going to give you an error message or tell you it's no such number. So this is no good. We can't take the log of a negative number. You can't raise e to a power and get something negative. So this is not a solution. So negative 1 is no good. That's an extraneous. Okay? Don't try telling me it's a solution. Okay? So let's try the other one. So g of 2 gives us natural log of 2. Well, we don't see natural log of 2 as an answer. It'd be nice if we just had that listed as opposed to these decimals. But we can use our calculator. I'll do that real quick, and you can see what natural log of 2 is. And so natural log of 2, include that. All right, so 2 natural log, it's 0.69. So, oops. Well, I'm the one that wrote the question, so I don't know why there's a negative in there, but it doesn't belong. So I will fix that. I typed it up and I accidentally typed a negative in there. So positive 0.693. We know that that wouldn't be a negative number. It'd be a positive. So there we go. That's our answer. That's our solution set now that I fixed my second value there. And that's our answer. And we can check it in the other equation as well. It might not be a bad idea. So let's plug it back in the other one. So we have f of 2 equals natural log 2 squared minus 2. And that would be natural log 4 minus 2 is 2. So we got the exact same answer. These two do check out, right? If we set them next to one another, we get natural log of 2 equals natural log of 2, which is a true statement. And I just had a little typo there. That should be a positive 0.693. I guess I saw imaginary negative there. All right, so these are the kinds of questions you can expect to see on systems of equations. And if you have questions, let me know. Hopefully these made lots of sense to you. And in the upcoming podcast tomorrow, we're going to look at solving exponential functions. We're going to be looking at exponential growth and decay, our sequences, and the graphs. I've already been on, this podcast has already gone on 26 minutes, so I'm going to end it, and I'll see you later.